I'm Pat Baskfield. I'm a hydrologist with the Minnesota Pollution Control Agency. And we're here today on the banks of the Watonwan River in Watona Park in Madelia. And I've been asked to talk about water quality, in particular sediment for this section. And sources of sediment, how the river has changed over time as far as the sediment load it carries. And it's a rather complex issue. If I look at change, I've been here for 20 years now, and I spend a lot of time on the river. I live about 5 miles downstream right on the river. And in a typical year, I'll go down maybe once a week, something like that. So I see a lot of change. I've seen a lot of change over time, and I've seen a lot of change over the course of any given year. When I first moved here, if I look at sources of sediment for the river, here the river's, it's pretty close to being at gradient with the surrounding landscape. So the primary sources of sediment were predominantly in agricultural landscapes. So we certainly have erosion from agricultural fields. We also have stream bank erosion. Both of those are natural processes, not a plowed field, but surface erosion and stream bank erosion are natural processes. But the rates of erosion have greatly accelerated over time. What I saw when I first moved here, there's been a lot of good that's gone on in the landscape, different conservation practices, conservation tillage practices, more residue, what's remains of crop after harvest, that's allowed to stay in the landscape. And so when we get the spring rains, that promotes, it slows the water down, promotes infiltration, maintains soil integrity, and that's helped a lot. So we get less overland flow because of that. There's also been various programs, Crop Conservation Reserve Enhancement Program, where 100,000 acres of land went into, these are erodible lands, went into grass and other set-asides. CRP, Conservation Reserve Program, where again a lot of environmentally sensitive lands, erodible lands, have been set aside in various programs where native vegetation has been reestablished. But when I was first here, there was not a lot of lands enrolled in these programs, and I saw the surface erosion component being much greater in the river. We get a hard rain, particularly when the crop canopy is not developed. So early spring after snow melt, usually about mid-May through the end of June, we'd get high-intensity rains. Raindrops would hit the unprotected soils, dislodge soil particles, carry those to the rivers. But the river would be incredibly brown. It's brown today. We've had some rain lately, but it used to be much worse than this. And after flows receded, there would be a lot of sediment that was settled out, and it really made for a very unappealing river. I spent a lot of time kayaking and fishing on the river, and would often take my kids down. And I remember my kids walking on what would have been a sandbar, prior to all the sediment settling out, and shoes being lost in 6 inches of mud as they tried to walk across the sandbar. And I don't, I still see sediment settling out. You can see here, or maybe later on we'll take a picture, but there's a lot of sediment settled out here, maybe, I don't know, half to 3/4 of an inch from the last rain event. So this is coming from fields and stream bank erosion, but it used to be much worse than this. That I've seen get better. There's also been a shift to more intensive drainage on this landscape. So we've had a shift in sediment sources from when I first moved here 20 years ago to now, and granted, we still have a lot of overland flow during that critical, mid-May through end of June time period, and a lot of sediment carried with that. But with these conservation practices, the water quality is better. But we also, I guess on the other side of the fence, we've had increased drainage. Drainage is fabulous for growing crops. It's a money maker. It makes a lot of sense for agricultural producers. But for river enthusiasts like myself, this river has evolved to carry a certain volume of water and a certain hydrologic regime, and that has been offset. And eventually I saw a transition, from the overland sediment contributions being lessened, but then I saw I saw more stream bank erosion, and what's happened in this landscape. There's been a real increase in the amount of subsurface tile drainage. Tile are plastic perforated pipes that are set in the agricultural landscape, every 40 to 60 feet approximately, to help drain excess moisture, and it's a winning solution for farmers and production. Yields are increased. The payback is rather short-lived, but it's had an impact on the river. What happened is now the river's carrying more water than it has evolved to carry. This river, was formed 10,000 years ago after the last glacier, and over the course of time, its channel, it certainly meanders, but it's reached an equilibrium where the width is kind of has been dictated by the hydrologic regime, and now we have more water going through this system, and it's going through a lot faster. When it rains, the water goes through these pipes, makes it to the river in a matter of minutes to hours to days, where once upon a time everything went through the soil profile. It took a lot longer for that water to make it to the river, and consequently peak flows have increased and the total volume of water that reaches the river has increased. It's also been wetter, so we have more water, naturally from climatic patterns. But the drainage components has really caused a widening of the river. River, when it gets more water, it will either cut down or it will widen. There's a lot of gravel in this river, and there's structures like bridges that keep rivers from cutting down. You don't want to hurt the infrastructure. So these rivers are widening more than cutting down. And so what happens now, I go down the river, and there's trees all over the banks of these rivers. The rivers have gotten much wider. The flows come in short bursts. So then when everything's drained, the river falls very fast. And we have a river that, once upon a time went through a much narrower channel, but now under low flow conditions, we have a much wider channel. So when these low flows come through, we have that water spread out over a wider area, and it's much shallower. So sometimes you can't even get a kayak through the river. It's so shallow. And from a biological standpoint, benthic or bottom living species, they have a hard time. I fish this river a lot. I've lost a lot of fishing holes. The river is now basically it's the same flow under low flow conditions, but in a much wider channel, and so the deeper holes are no longer there. It's just a wide, shallow river, almost kind of a dishpan shaped river in these channels.